Okay, we know that the tangent of x has derivative secant x squared. So naturally, by the definition, the antiderivative of secant of x squared is tangent x plus c, right? So this is a natural one. Now let's discuss the antiderivative of secant of x cubed. See what this is. The formula is that it is 1/2 times secant x tangent x and plus natural log absolute value secant of x plus tangent of x and then plus c. All right, now let's see how do we uh, find this formula. The traditional way is to apply the integration by parts. So how do we do that? We're going to write secant x cubed as secant x times secant x squared. And then we will consider this as a u, this as a dv. Remember the integration by parts is that u dv is equal to uv minus v du. And if dv is secant of x squared dx, then v is tangent of x by this formula. So let u be secant of x. Dv is secant x squared dx, so v is tangent of x. And then u is here, then we need a du, then du is secant of x times tangent of x dx. Okay, so by the integration by parts, let's see it, it's a u times v, so it's a secant of x times tangent of x, a minus the integral v du, v is tangent of x, du is here, so it's a secant of x tangent of x dx. All right, okay, and let's continue. Copy secant x times tangent x. Here you have tangent x, you have tangent x squared. And tangent of x, we know tangent of x squared is equal to secant x squared minus 1. Tangent x squared is secant x squared minus 1, so we apply this identity in this integration formula. We have secant x times secant of x squared minus 1 dx. All right, so here, let me rewrite this. So this one, I copy it. It's the left-hand side. And right-hand side is secant of x times tangent of x, a minus secant of x cubed dx, and plus secant of x dx. See? And then we're going to move this term to the left-hand side, combine with the left-hand side. So you got twice of a secant of x cubed dx is a secant of x times tangent of x, and plus what's this? Antiderivative secant of x, we just computed. It's a natural log secant of x plus tangent of x, and then plus c. So we divide this equation by 2, we will get our formula. It's 1/2 secant x tangent x plus natural log secant x plus tangent x, and then plus c. Right? So this is the standard way to find the antiderivative of secant of x cubed. Now let's try to use a partial fraction to do the same to do the same problem. All right, the partial fraction. Well, secant x cubed dx. Secant x is 1 over cosine, so it's a 1 over cosine x cubed dx. And we're going to multiply top and bottom by cosine x, so it's into cosine x over cosine x to 4th power dx. Then cosine x dx, so if we let x be, u be sine of x, then du is cosine x dx. Then cosine x to 4th power is cosine x squared and then squared. So it is actually 1 minus sine x squared and squared. Sine is u, so it's a 1 minus u squared squared. Okay, 1 minus u squared squared. So this integral, let's follow it. The integral becomes du over 1 minus u squared squared. So we're going to use partial fraction this place. This partial fraction is the following. 1 minus u squared squared is 1 over 1 minus u difference squared times 1 plus u, the sum squared. If you apply the partial fraction, that's a little bit long because we have 4 terms. So you will get 1 over 4, 1 over 1 plus u, plus 1 over 1 plus u squared, plus 1 over 1 minus u, plus 1 over 1 minus u squared. Okay, just try it by the partial fraction, you will get this. Okay, so once we have this partial fraction, we're going to have 4 terms, remember that. So it's integral, the first one, 1 over 1 plus u du. The second one, 1 over 4, integral 1 over 1 plus u squared du, and 1 over 4, 1 over 1 minus u du, and plus 1 over 4, 1 over 1 minus u squared, and du. And then we look for the antiderivative for each term. So this one has antiderivative natural log absolute value of 1 plus u. And this one has antiderivative minus 1 over 4 and over 1 plus u. Okay? And this one you will have plus 1 over 4 natural log absolute value of 1 minus u to power negative 1. You can put the negative 1 forward as a minus, but I like to put it as a negative power. And plus 1 over 4 and 1 over 1 minus u. These two, you just use substitution, use the power rule for the antidifferentiation. These two are the definition of a natural logarithmic function. All right, and then you're going to put these terms, 2 terms together, and these 2 terms together. All right, so put the first and third term together, we get a 1 over 4 natural log absolute value of 1 plus u over 1 minus u. These 2 terms, you put them together, you will get 1/2 and u over 1 minus u squared, and then plus c. This is the product. Okay? Okay, now let's continue. U is a sine of x. U is sine of x. So we get 1 over 4 natural log 1 plus sine of x, 1 minus sine of x, plus 1/2. The numerator is sine of x, and denominator is 1 minus sine of x squared, and plus c. And for this one, we're going to multiply top and bottom by 1 plus sine of x. 1 plus sine of x squared. The denominator will also multiply 1 plus sine x squared by the difference of square formula. We get 1 minus sine x squared. And here this 1 minus sine squared is a cosine of x squared. Alright, and here this becomes cosine x squared. Here is 1 plus sine x squared, so there's square. 1 plus sine of x over cosine of x, and then square plus sine x over cosine x squared is equal to secant of x times tangent of x. It's a secant of x times tangent x. You just separate the cosine, and its denominator becomes cosine times cosine. Sine over cosine is tangent. 1 over cosine is secant. And here, this power 2 cancelled with 1/2. You have also 1/2 natural log 1 over cosine secant of x, sine x over cosine x, tangent of x. Here you also have 1/2, so let's factor out 1/2. So we still have the same formula, right? Okay, so this is the complete process to find the antiderivative of secant x squared and secant x cubed.